Good morning, sir. Good morning, ma'am. In this project, we are working with forging with torsion, where the forging process is modified by adding torsional moment. So it has some effect on regular upsetting process, and it has some advantages. So what is forging? That is deforming the material, and the way we deform the material is changing. And about the material used in the workpiece, I would like to hand it to Pratik.
Medium carbon steel is the raw material, and the density is 7.85 gram per cm3. Accessory pad like studs, gears, shaft and axle, which is used in automotive industry.
This is a partnered product from the RSB project. So basically, RSB performed this project by upsetting. So we made a modification with the upsetting with torsion. This is a pre-forming process. After that, this is a with torsion, upsetting with torsion. So we can get the sectional view of the temperature variations of the product and the sectional view of the stress variations of the product. These are the advantages of FWT model. Basically, it takes lesser deformation force than the upsetting, and more temperature can be obtained, and it can be modified easily, and results in an uniform strain distribution throughout. And the parts with high density and decreased porosity. This is a investigation that we have done at the centroid position.
Our part in this project is to numerically analyze what is going on in the workpiece that we are going to see just right next slide. And the methodology says that this is upsetting followed by upsetting with torsion. And this is how we did the analysis. We changed the velocity of the tool, changed the velocity of the angular rotation of the tool. Now this is the workpiece we investigated, and we chose 5 points here. Out of these 5 points, we wanted to know what is going on at the centroid of the workpiece, because we might get a hint about how the defects can occur in the bulk of the workpiece at the centroid and regions surrounding the centroid. What our motive is, we want to optimize the product, optimize the workpiece before it goes into actual experimentation, so that it can reduce experimentation costs of the industry. Here are the graphs that we have obtained, the accurate graphs that we have obtained at the center of the workpiece. This is how the temperature is varying for the upsetting process. This is how it is varying when the torsional moment is added here. You can see there is so much of changes. Then same thing we did for the stress, for the strain rate, and this is what we have obtained at the volume of the workpiece, like at an operation, how much is the maximum temperature coming, stress coming and strain rate coming. And from these type of information we can predict necessary defects, and we can observe changes and therefore rectify it easily. And this model right here, this model is very simple, so it's very easy to analyze this model, and this type of model can be used in preforming of shafts, just like how my friend Pratik explained. Thank you.